Hello, our group is Group 31. Our topic is about security in Internet of Things. Now let's begin. First of all, please let me briefly introduce the IoT. The IoT is divided into three layers: application, network, and perception layer. Application layer is generally referring to some smart equipment for human services. The network layer is generally used to transmit data. The perception layer mainly perceives the information from the physical world and converts into data. Every layer has the possibility of being attacked. We must consider security issues. Next, I will start with the perception layer and introduce a serious layer threat and solution. There are really so many threats in the perception layer, such as medium interference and cracking password. But today, I will focus on the reply attack, which is the most serious attack for some devices in the perception layer. The attacker repeatedly sends data that has been authenticated to obtain identity authentication. So next, I will introduce a CQ which can solve the problem of reply attacks. This algorithm is based on the ECC algorithm, which can also be said to be a key agreement algorithm. FID devices have tags and readers that need to communicate with each other. The main process of this algorithm is that reader first uses the public key and random number to generate R1 and sends it to tag. Then the tag uses the public key and the random number to generate T1 and also generate C1. C1 is calculated by a private key and the R1 from the reader. After this, the tag transmits T1 and C1 to the reader. Next, the reader uses the random number and the public key to generate R2 and verify C1. After the verification, it uses T1, which is from tag, and its private key to generate C2, and then send back to tag. Finally, after the tag verification, both devices can get plain text. Here is the history of ECC algorithm for perception layer devices. As time changes, the algorithm optimization is getting better and better. Now it's very difficult for third parties to reply information under the algorithm because they cannot generate and pass verification information. However, due to the limited resources of the system, this algorithm is still a burden on the system. But I think ECC has great development potential in the future, and there may be more algorithms with lower complexity and better security. Next, my friend will introduce the network layer of the Internet of Things.
Okay, the network layer is in the middle of IoT model. Assume the network condition is unreliable and devices are limited resources. Therefore, the network layer protocols need to be lightweight and feasibility for many application scenarios. The MQTT protocol is the most common used message protocol in IoT. It has a publish, subscribe, message transport. The broker is like a service. MQTT protocol usually run over TCP/IP protocol. It has three-way handshake mechanism to set a connection. So the network transmission is prone to flooding attack and lose availability. This is an example of the flooding attack called SYN attack. The attacker keeps sending a large amount for SYN requests to MQTT broker and don't respond with acknowledgement. The MQTT brokers has to spend huge resources waiting for lots of half-open connection. At the end, the broker cannot respond to legal traffic. One defense method is to set SYN cookies. When the server receives the SYN packet, it will compute the cookie first and reply the craft SYN acknowledgement with cookies without inserting a new record to this SYN queue. Until checking the acknowledgement from client, the server verifies the connection. The algorithm of 32-bit cookie is on the right. It's divided into three parts. However, it's a compromise method. The cookie do not reduce attack traffic, and it will spend additional time and space for cryptography operation. In addition, there are other ways to deal with SYN attacks, like setting timer, filtering, and recycling mechanism. The MQTT service will also be subject to other attacks like UDP flood attacks. We will explore more detail in the report. Next, my friend will introduce the application layer.
Well, actually, the application layer is the ultimate goal of IoT development, and the main work of the layer can be summarized into two parts. First, the first part is intelligent processing of cloud data. The cloud service will provide intelligent processing of the data received from the transmission layer, which means it will clean up amounts of distributed information and then extract the data with high information value. The second part is application platforms provide services for users. The cloud will transmit proceed data to users, companies, or management departments, such as telemedicine web service, smart home device management APP, or intelligent transposition programs, and so on. Then these application platforms use the data to provide the required service for users. But remember, we need to prevent the disclosure of users' private information when using cloud service. To handle this question, homomorphic encryption method is required. It provides a function for dealing with encrypted data. The following picture shows the example. First, Alice encrypts the data and sends it to the cloud. Second, Alice transmits a method to the cloud for handling data. Third, cloud processes the data by using the method and then returns the result to Alice. Finally, Alice decrypts the data and gets a proceed result. This method effectively protects the privacy of data, so users can safely handle sensitive information through cloud service. In addition, homomorphic encryption can be classified as partially and fully. The detail is shown in the table. As we can see, partially can be divided into multiplicative and additive. Well, the fully is the combination of the two types. The homomorphic encryption has been continuously developed and improved with time passing by. In today's big data environment, IoT security protection is still a difficult task, and there is still a long way to go to achieve a comprehensive and reliable Internet of Things security system. Safety issues should continue to be taken seriously. That's all. Thanks for your listening.